Hi students, my name is Nitesh. Shet. I am from Manavara. So last class we discussed about a topic from 9th standard, that is circles. In circles we already discussed about what is meant by circles, what are the terminologies we have in the circle. Also we discussed about angles subtended by a chord at a point. We already discussed in that two problems and two homeworks I given to you. So let us move on to the next concept, that is the perpendicular from the center to a chord. The perpendicular from a center to a chord. Yes, that means here we have to take a chord and also we have to draw a perpendicular from the center. So that means here what happens is that perpendicular bisects the chord into two equal parts. So that one is the statement for the next theorem, that is theorem 10.3. The theorem 10.3 states us that the perpendicular drawn from the center of the circle to a chord bisects the chord. Here. So we have to take the theorem 10.3. It is theorem 10.3. Yes. So here we have to take the theorem 10.3, that is the perpendicular drawn from the, or a perpendicular from the perpendicular drawn from the center of a circle to the chord bisects the chord. Yes. So how can we prove that those things here? So here we have to take a chord. Firstly we have to take a chord here. So I will take it as AB. So I will take AB as a chord. So A and B are the any 2 points on the circle. A and B are any 2 points on the circle, and we joined those things, that is considered here AB is a chord. Here we have perpendicular, so we can draw a perpendicular. But remember here there is no any proof, so we can take the proof also. But here there is no need of proof, so here we can take the activity. So here in your syllabus, in your textbook, so there we have a activity here. Yes. So how can we take that one? So here you have to take a tracing paper. That means let us consider this is a tracing paper. Okay, so let us consider this is a tracing paper. In that you have to draw a circle. With the center O. Then what you have to do is, so we have to fold that paper. Such that yes, the folding passes through that, the folded part passes through this point M. So here that means here I will look it like this. So here the folding is like this. Here it is the tracing paper we have to fold here, and it passes through the point M. So it passes through the point M such that here the MB, this part MB completely overlap on AM. This part MB is completely overlap on AM, so such that line passes through the center and also it perpendicular to the chord AB. Also it bisects the AB into two equal parts, such that because so complete MB is completely overlap on AM, so also B touches the A here. So that's why After that we get AM is equal to MB. Also we get the perpendicular from the center to this chord AB here. So what we have to do here? So we have to take a tracing paper and then we have to draw a circle here. Then we have to point out the center. Then we have to draw a chord AB here. Then we have to fold the tracing paper such that it passes through the point M on the AB. So and if it is MB touches completely, this MB is completely overlap on AM means, so then this OM is the perpendicular to AB here. So it is from the activity we can prove those things, that is AM is equal to MB. So here we have to take the activity. That is, so here in the figure OM is perpendicular to chord AB, then OM bisects AB. OM bisects AB. Therefore, AM is equal to MB. AM is equal to MB. So from the activity we get this thing. When we draw a perpendicular from the center of the circle to a chord, this chords bisect into two equal parts. So let us move on to the converse of this theorem. So we have to prove that the converse of this theorem also true. Let us take the converse of theorem 10.3. So in theorem 10.3 we already discussed about the perpendicular drawn from the center of the circle bisects the chord. So we already discussed. So here we don't have to take it's not a perpendicular, it's only the line from the center of the circle. It bisects the chord means is perpendicular to the chord. We have to take like that. So we have to take the reverse order of that one. Yes. So let us take the theorem 10.4. Theorem 10.4. Yes. So if a line is drawn from the center of the circle to the chord, center of the circle to bisect the chord is perpendicular to the chord. We have to take. If a line drawn from the center of the circle to bisect the chord is perpendicular to the chord. Is perpendicular to the chord. We have to prove that one. So that is, so we have to draw a perpendicular. Here we have to draw a line here. So here it's a line we draw. And firstly we have to write the given things. What are the given things here? O is the center of the circle and OM is the any line touches the point M on AB such that AM is equal to MB. So that is one is the given. So let us we have to take the given things. So given, what are the given things here? So that is O is the center of the circle. O is the center of the circle and OM is the line drawn from the center of the circle to bisect the chord, chord. So what is the chord here? Chord AB. So bisects the chord AB such that AM is equal to MB. Bisects the chord at point M. AB at point M, that is AM is equal to MB we have. Then what we have to prove here? So we have to prove that angle OMA is equal to angle OMB is equal to 90 degrees. That is to prove what we have to prove here. So angle OMA is equal to angle OMB is equal to 90 degrees. That means here OM is perpendicular to AB. So we have to prove OM is perpendicular to AB. We have to prove. So those two are same. So firstly we have to take this thing, and then we have to take this thing. Yes. So let us take the proof. So before that, any construction is needed. Yes. So one construction is needed because there is no any triangles here. So for that we have to draw a radius. So we have to draw radius. Construction. Draw OA and OB radius. So here we have to draw the radius here. Yes. So here I will draw the radius, and here I will draw the radius here. Then we have two triangles here, so we have to consider two triangles here. So let us take the proof. Consider triangle OMA and OMB. Triangle OMA and triangle OMB. So in that, what are the equalities we have? So already we know that radius of the circle, whatever the number of radius we have, all the radius of the circle are having equal lengths. That's why OA is equal to OB. OA is equal to OB because it's a radii of circle. Then, so another equality. So here just observe, OM is common for both the triangles. So that's why we can take OM as the common side. OM is equal to OM because it is common side. Then also it is given that here it is given that it's a equal chords. So it bisects. So it's not equal chords, that OM per line bisects this AB into two equal parts at the point M. So that means we have AM is equal to MB. That is AM is equal to MB because it is given. So here just observe there are three sides, three corresponding parts of congruent triangles. That is, sorry, it's not a congruent triangle. Here it is the two triangles we have. So in that corresponding parts, three pairs of corresponding sides are equal. So that's why we can take it as a side congruence rule. So from side congruence rule we can take those two triangles are congruent. That is, from SSS congruence rule, we can take triangle OMA is congruent to triangle OMB. When we have those two triangles are congruent, all the other corresponding parts of congruent triangles are equal. That is, angle OAM is equal to angle OMB, it is also equal. Then angle AOM and angle BOM also equal. So which one is needed for our proof? So this one, angle OMA is equal to angle OMB. Therefore, angle OMA is equal to angle OMB. So because it is CPCT. Here it is not. The proof is completed because we want angle OMA is equal to angle OMB is equal to 90 degree. How can we prove that one? So you just observe AB is a line segment. When a ray OM stands on this line, the adjacent side, adjacent angles formed is 180 degree. So that's why it becomes these two are the linear pairs. So let us take that one condition. Yes. Consider OM ray stands on AB. OM ray stands on AB line segment. Then the linear pair is we have that is OMA, angle OMA and angle OMB. That is angle OMA plus angle OMB is equal to 180 degree because it is linear pair. Because it's a linear pair. Then here we have angle OMA is equal to angle OMB. So that's why we can insert angle OMB in place of angle OMA or angle OMA in place of angle OMB. Those two are same. That is angle OMA plus angle OMA is equal to 180 degree. So this implies 2 into angle OMA. This means OMA, angle OMA plus angle OMA. So it is 2 into angle OMA is equal to 180 degree. So this implies I will transpose this 2 to the RHS side. It becomes angle OMA is equal to 180 degree divided by 2. It is angle OMA is equal to 90 degree. So then we can take angle OMA is equal to 90 degree means angle OMB is also 90 degree because angle OMA is equal to angle OMB, angle OMA is equal to angle OMB is equal to 90 degree. Therefore, OM is perpendicular to AB. So we proved our theorem. So after the proof we can take it as a true. So that means the perpendicular drawn from the center of the circle to the chord, it always bisects the chord. So it's a perpendicular to the chord. Perpendicular to the chord. Then if a line is drawn from the center of the circle to bisect the chord, means that one is also perpendicular to the chord here. So here it is the proof of this theorem. There is no any such problems related with these theorems. So here it is the theorem proof part is enough to you. So those who are watching this video for the first time, please subscribe our channel and don't forget to press the bell icon. You can get the notification of our channel very easily. Also hit the like button. Thank you one and all. Be safe and stay home. Thank you.